today's Bootcamp session, we're going to be talking about front-end integration on Starknet. Basically, how we can interact with our deployed smart contract using a front-end. And for today's session, we're going to be building a student registry DApp. And we'll be talking more about that later. But first of all, we need to understand some terms. Okay, so we have some slides for today. So welcome to today's session again. So we're going to be looking at a couple of things very quickly because our time is going to be fast spent. So again, I'm Oshioke Salaki and these are my socials. So let's look at the first thing we're going to be looking at is ABI, which is the application binary interface. So what's an ABI? An ABI is basically a blueprint that defines how we can interact with our smart contract. It specifies contract functions and what parameters they take and how to format data for calls. ABIs basically serve as the DNA of a smart contract. So you know how if you create a smart contract in Cairo, you have functions that are either read or write functions. So the ABI basically just shows us like a structure of how our contract is. How many write functions we have, how many read functions we have, the inputs that they take in, and the outputs that each function gives out. So we're going to be looking at how a sample ABI looks much later. But that is what an ABI is. It's basically the DNA of a smart contract in Starknet. So the next thing is, what is front-end development? This is the process of creating parts of a website or web application that users can see and interact with. So think about things like Twitter, Facebook, Google Slides and all that. Those are applications that we can interact with. We can click on buttons, we can swipe left and right, we can go to different pages. So it involves using programming languages like HTML, CSS, and JavaScript to design the layout, appearance, and features that make a website look good and function smoothly. So then there's thing called front-end frameworks. These are tools that help developers build websites more efficiently. They provide pre-made structures and components that make it easier to handle complex tasks like displaying data and interactions and other things. Before frameworks, it was quite tedious to create single-page applications or websites, in which it involves a lot of repeated code and repeated functionality. But with frameworks, it makes it easier to do all of that. So, for today, we're going to be using a front-end framework called Next.js. That is why I'm trying to define what a front-end framework is. So we also have things called front-end libraries. These are libraries that basically help us to interact with Starknet and our smart contract. So depending on what you are building with, there are different front-end libraries for it. If you are building with Rust, we have Starknet Rust, which is used to interact with your Starknet smart contract. If you are using Python, we have starknet.py, and if you are using JavaScript, you have starknet.js. In starknet.js, you also have starknet react and starknet kit. So I don't know if everything is clear so far, and I hope you guys can hear me. Everyone can hear me, right? Okay.
Yes, we can hear you.
Yeah. So what is starknet.js? So starknet.js is a tool that helps developers to connect their DApps to Starknet. It enables easy interaction with smart contracts, such as sending transactions, which is writing. Because as we all know, when you're calling a write function, you're sending a transaction to the blockchain and getting information from the blockchain. Getting information from blockchain is done by calling read functions in a smart contract. Then Starknet.js also helps us to do things like checking transaction status or reading contract data. So I also provided a link there for Starknet.js. Then we have Starknet React, which is a library that provides tools and hooks to interact with Starknet itself, making it simple to connect users' wallets and fetch blockchain data directly from React components. So for this coding, we're going into the coding session, and the requirements that we have are we need a code editor, so like VS Code. Then we have Node.js. Then we need an RPC provider, which we're going to be doing together, the contract address, the contract ABI, and the starter code. So let's get straight to the coding aspect. So I sent a repo to the repo. You have this code, and if you fork it and clone it. This is what we have. So in this repo, we have two folders. We have the contract folder and the student registry DApp starter. Then we have assignment.md and readme.md, which we are going to be looking at later. So let's look at the contract folder. So this contract folder, what it just holds our contract that we're going to be interacting with, which is the student registry contract. So I hope everyone can see my screen clearly. So in this contract we have,
Yes, we can see your screen.
So in this contract we have 5 functions. We have the get students function, which is a read function to get a student by its particular index. We have a get all students function, which returns a span of students in an array. Then we have the add student function, which adds the students to the registry. I think there's a question.
No, I'm just sharing the repo in the group. Yeah.
Okay. So we have the add student function here. So this function basically adds a new student. Then we have another function, update students and delete students. So update to update the students' information, delete students. I'll talk about that later towards the end when I'm giving the assignments or the tasks for the session. So that is basically what this function does. So that's basically what all this contract does. And this contract has been tested and deployed, and we have a contract address. So to get that contract address, if you go to this student registry DApp starter folder, this is what we are going to be working on. So I already prebuilt some components that we'll be using so that it can speed up the process. We don't have to bore ourselves with the unnecessary parts, so you can get straight to business. So we have this folder, and this application was actually built with Next.js, which is a front-end framework, a JavaScript front-end framework. So the first thing you do is that when you open your terminal, you need to cd into this folder. So cd students like this. So when you cd into this, then you need to install your dependencies. So npm I -- legacy. We have some peer dependencies that I wasn't able to fix at the time. So we'll have npm I -- legacy peer DApps. This is to install the dependencies needed for this application. Okay, I misspelled legacy wrong. Legacy peer DApps. So after that, we can see how the application looks by running npm run dev like this. So if you open this in your browser, so if you open this in your browser, this is how the application looks. So we just have a basic layout here. So we have the Starknet logo, then we have this address bar to show the address of the connected user, where we can copy the address. Then we have a disconnect wallet button. None of this is functional, by the way. We have a students table here. We also have a wallet balance. This is to show the balance of a connected wallet to the DApp. Then we have the students table, where we can see all the students and their information. Then we have the status of the students, whether the student is active or inactive. Then we have some action buttons to edit the students, to delete the students. The edit and delete students are not functional at all, which you guys will be doing later. Then we have a refresh students button, which is meant to help us to refresh students. Then we have an add students button here, which pops up this modal so that we can impute the students that we want to update. We want to add. We'll add a student, and when we submit it, it's meant to call that add student function that we defined in our smart contract. Then we have a filter to filter between active or inactive students. So you can filter it like this. So this is how it works, right? Then we have a small pagination section here where we can toggle between pages and all that. So this is how the layout of the application works, and none of this is actually interacting with a smart contract. So we are going to be bringing this application to life in the sense that it's going to be interacting with this deployed smart contract that we have. So yeah, let me just walk you through the code base so that you can see everything that we have. Okay. So yes. So for the styling of this application, we are making use of Tailwind, which is a CSS framework. So we just have some basic scaffolded files here. So then this is the node modules. This is the modules that make up the application, that make the application to work. So package.json, this shows all the dependencies that this application makes use of. So remember when I talked about Starknet libraries that we have for front-end integration, when we mentioned Starknet REact, then we also mentioned Starknet. So let's take a look at their documentation. So we have Starknet JS here. Then we also have Starknet REact. So these are the libraries that we're going to be making use of in this application. So it's a bit slow to load, but we can move forward. So the first important file that we have is the layout file. So this is the first point of contact when this application is loaded in simple terms. So this defines that we are working with HTML. Then this is where the body is being rendered here. So then we have some metadata such as the title, the description. So then we have the page.js. This is where we start coding from. This is where we start working from. So we have some sample code here, which is not really functional. So we're going to be bringing it to life step by step. Then we have the components. Folder. So sorry about that. So we have the components folder, which we have some prebuilt components here that make up these applications. I'll be going through them one by one. So we have a simple to-do list here to show what we need to do. So if you go to the README, this README, the first thing that we're going to be doing is getting an RPC URL. What's an RPC URL? An RPC URL is basically a link that helps us to interact or make calls to Starknet, to the blockchain, to Starknet blockchain. So, and how do we get our RPC URL? You come to so you can either get it from Infura or you get it from Alchemy. I personally like to use Alchemy. So these are RPC providers in the Starknet ecosystem. So you create an account or you sign in if you have one already. Alright. So network is a bit slow. I'll start talking about how to get our RPC URL from Alchemy, which is an RPC provider on Starknet. Okay, so after you've created an account, you come to your dashboard like this. Then you can create something called apps. So if you create an app, you can just create it. Then I already have some apps here. So if I click on any of my apps, I can just get the endpoints. So you come to the endpoint, then you see Starknet here. So we're going to be building on Sepolia. So you make sure that you have Sepolia selected here. Then you copy the HTTPS URL. So that's the RPC URL. And where are you going to put it? So in frontend development, we have something called environment variables. So if you have something called env.example, and you see that is the first thing that we need to do to impute our RPC URL from either Alchemy or Infura. So what you just do is that you create a new file called .env.local, then you paste in your URL, your RPC URL that you've gotten, like this. So then you paste it in like this. So that's the first thing that we are doing. The next thing that we are going to be doing is, let me put, the next thing we are going to do is that we are going to set up our providers. What are providers? Providers is basically what we wrap our whole applications on, such that Starknet and its tools can be easily accessible from everywhere in our application. That is what the providers does. So we are going to just, it's as simple as, so this is like the most complex part, but not really complex. So if you go to your components folder, you have this providers.jsx here, like this, providers.jsx, and that's the second thing, set up our providers. So it's still a component, a JavaScript component. So the way you do is that you do export function then providers, then we pass in the children prop, which what the children means is that anything that is wrapped in between these providers is going to, that means Starknet is going to be available to everything. So we're going to be wrapping our whole application within the providers. That means the whole application is basically the children. That is as simple as I can explain, because I don't know if people here are new to front-end development using React or Next.js. So I'm going to try and breaking it down as simple as I can. Okay, somebody asks what is Sepolia. So Sepolia is basically a test network. So we have mainnet and Sepolia. So imagine when you are building, on mainnet is the real thing where you have real money. So imagine you building an application and you want to test it. You want to test your application. And whenever you are calling write functions, you need to pay gas fees. So imagine as you are testing, you need to call that write function 200 times, 1,000 times. So your real money is going as you are testing. That's if you are doing it on mainnet. So they created something called Sepolia, which is testnet, where you use fake money. You use fake crypto like fake it. Actually, it's not actually fake. It's test it, test stack, and so on. That you can use and use and use. So it's not real. So which enables you to test as much as you want. So that is what Sepolia is, and that is why we are building on Sepolia first. So you build on Sepolia first, then after you've tested everything and everything works perfectly, then you can now deploy it on mainnet. So that's how it works. So yeah, I hope that answered the question. So back to writing our providers. The first thing that you need to do is that you need to get your connectors. So connectors like this. So connectors is equal to, so we have something called use injected connectors from Starknet React. So for connectors, you know how when you are creating accounts in Twitter or Facebook, you have to, when you're creating accounts, they say sign up with either your Gmail or phone number. That's how it works in Web 2, right? But in Web 3, we don't connect with our Gmail or phone numbers. We connect with our wallets. Our wallets serve as the main identity of every user in a DApp or blockchain application. I hope that is clear. So we're going to set up our connectors, and there are two major Starknet connectors, which are Starknet wallets, which are Bravos and Agents. So if you in your browser, you can easily download them. So this is the logo, Bravos. This is Bravos, and you have agents here. So, so let me just go to their website. So Bravos. So we have Bravos wallet here. Let me paste the link. Then we also have agents wallets. So these are the two major connectors in the Starknet ecosystem. So this is also agents. So for the connectors, for the injected connectors, you need to pass in an object here. So you have the recommended property. So it's an array. So you place so you see agent, you import agent again from Starknet React. So you call the agent function, then you call the Bravos function. This is also, so it's automatically imported for us like this. So this is the Bravos, we are calling the Bravos function. The next thing is that we need to include recommended. So we say only if no connectors. Then we have order. So you can either do it random or alphabetical, anyone that is preferable to you. So let's just say random. So random. So when we call this function, it returns a value which is called connectors to us that we can use in our application. So now we're going to now return the providers. So we're going to return something called starknet config. So starknet config like this. So in this starknet config, this is where we put our children. But this starknet config receives some props, such as we have the chains. So this is where we specify the chain, and we're going to be making use of Sepolia, as I said earlier. Sepolia, because we are testing. Then we're going to put our provider. So for our provider, we're going to call this JSON RPC provider function like this, and this function takes in an object here, which takes in an RPC value, which is also a function which takes in a chain like this. It's also an arrow function. Then so this returns an object to us. So we have the node. So we have the node URL. So since we have remember we have saved our RPC provider link in our env as an environment variable. So if we want to make use of an environment variable, the way we do it is that we do process.env.next. So whenever we want to call a environment variable created with next, we have to prefix it with this next underscore. So next underscore, then the name. So we have public RPC URL like this. So if we copy, you can just copy it directly here like this. So that is for the provider. So it's supposed to be. I don't think we need this. Okay, so just like this. So yes, so that's for the RPC. Then that's for the provider. The next prop that it takes in is the connectors that we get from up here. So we're going to say connectors is equal to connectors again. Then we have the explorer. Then for the explorer, we're going to be making use of Voyager, which we're importing from Starknet React also. So that is basically it. So this might look like a lot to keep in your head, but one thing is that this is pretty standard. In every application that you build, you are always going to have it in the same format. there's nothing that is really going to change, even if you want to try it on your own. There's no difference. So what you could just do is that you could copy this file and keep it somewhere. So at any time you want to build an application, you can just copy paste, then change anything that you might need to change later. So I don't know if there's any question in the chat. I don't know. Matthew Text, was I able to explain what a polyar is? Did you understand what I meant?
Yeah. I was just asking for a novice. Yeah. So
Okay.
yeah.
No problem. So
Maybe
does anybody have any question from this?
maybe what is a provider?
So so basically what a provider is that a provider serves as a container from which your application can be able to access Starknet hooks and functions. So think about it like this. Let's say you have Starlink. I know maybe you all know what Starlink is. So assuming you set up Starlink in your house, it means that your whole house is wrapped in a Starlink connection. Anybody that is outside your house cannot access your Starlink internet because they are not within the house, right? So think about providers like that. So provider wraps your whole application. So within your application now you can make calls, you can make function calls to Starknet, and it's going to respond because you are within the environment that is allowed to receive such responses. I don't know if that is clear.
Yeah, I get it.
Yes. So that is what? So that's what it is. So if everyone is like on the same page with me, can you leave a thumbs up so I know that we are moving?
Yeah, we're on the same page.
Okay. So if we're on the same page, so we're going to move on. So we're going to move on to the next thing. So now that we've set up our providers, I said that we need to wrap our whole application. So the way we do it is that in our layout here, you see something here, import providers here. So what we're going to do is that within our body, we will call the providers function. We'll call the providers components. Then we will paste our children inside it. So this is how we wrap our whole application. This is how we wrap our whole application within our providers. So I hope it's clear. So now what is the next thing that we need to do? The next thing we need to do is we need to implement the connect functionality. How do users connect to this application that we have built? How do we connect? So if you come to our components, you see something like a connector.jsx. So this is what we're going to. So this is connector.jsx. So let's go back to our browser. Okay. We have an issue here. Use content. Okay, providers. We need to let me just do something. So use clients here. So use found for Sepolia. So we have said no provider found for the chain Starknet Sepolia. So I think Sepolia. So I think we have an issue here. I think let me try and restart the server to see whether it works. So there's an issue. we've run into an error. No provider found. Why? Provider.
You haven't closed Starknet config. Is it supposed to be like that?
I have it what?
Ah, no, it's fine. It's not that.
Okay, yeah. Okay, I think it's this page. Okay, expected. Okay, I think this is an issue. So it was basically a comma. So right here we had this instead of this. So sometimes coding, that's how coding is. You have to figure out how where your error is. So we're back here. So let's go back to our connector. So normally we're supposed to have a connect wire button here. So let's see. Um, so we have this connect wallet. So if we click it, we have a modal here that's supposed to show the connectors that we need, which is Argent and Bravos, right? So so that's the next thing we are going to set up. So we have this modal here. This is where we're going to set up the connectors that are going to connect a user to this DApp. So what we are going to do is that right here, we're going to fetch the connectors that we have that we are getting in this application. So we say connectors. How do we get the connectors? The connectors that we've established the connectors here in our provider. So how do we get it globally? So the way we can get it is that we call a hook called use connect. So we have const is equal to use connect, which is coming from starknet react. And use connect returns two variables. We have the connect variable and also the connectors variable, like this. So if you go to starknet react documentation, we have, let's look at the use connect. So we have the use connect here. So this is a hook for connecting to a starknet wallet. So you see, what does it return? We have it returns. So you see everything that it returns. Okay, so you can see all the different hooks that we have for starknet react and see how each of them works. So back to what we're saying. So it returns the connectors, and let's see what these connectors is. So if we do console.log connectors like this, so let's check it out. So you see that we have an array here, and we have an injected connector. For the first one, you see that the ID is Bravos, right? And for the second one, you see the ID is Argent X. So these are the two connectors that we've specified. I remember when we said that we want it to be random. That is the order. So if we refresh the page, you can see you might notice that Argent will come out first. So if you see, so you see that Argent was the first one, and the second one was Bravos. So that's what this order does here when we specified it to random here. So for these connectors now, we can loop over these connectors to create the connector buttons. So we do connectors dot map like this. Then we pass in. Then for each connector, we want to return a button. For each connector, we want to return a button. So the button will say connect, then connector dot id like this. So in this button now. This button, we're going to pass in some props in. So we have the key, the connector, that which is going to be the connector.id. Then we're going to have the on click. What is going to happen? What's going to happen when the button is clicked? But for now, let's leave it empty. So let's just see how it comes out. So if we come back here, you see that we have this connect agent x, connect bravos. So you see that there are buttons. So we have some classes that we're going to add to this button to make it look like actual buttons. So let us add some classes first of all. So we have class name. Let's give it border block, rounded MD, text black, font regular, PY2, PX4. So I'm supposed to have this copy pasted somewhere, but I don't know why it's not. I think I forgot to do that. So we have capitalized and shadow. Let's give it a bit of shadow. So shadow MD. So I think if you come back, so it does not have a background. So let's give it a background. Let's say BG blue. Let's give it like a blue background. Then we have text white. So yeah, so these are the buttons that we have now. But right now, if we click on each of the buttons, they don't do anything because we have not called like the connect function that we have. So you see this, we also get this is the function which is used to actually connect the DApp to the wallet. So we need to hook it up here on the on click. This is an event handler. So whenever any of these buttons is clicked, what we want to do is basically call the connect function, and we need to pass in the connector. So we say connector should be connector like this. So this is what it is. Then we have to connector. So this basically, so we call the connect function, and we have to pass in an object that has the connector property set to the connector that we have here. So if we now come here, if we now try to connect to our agent, you see that our agent wallet pops up. So we need to input our agent password. So like this. So our wallet has been connected successfully. But how do we even know? The first thing that we need to sort out now is that whenever a wallet is connected, we need to close this folder, which is very easy to do. So the only thing we just need to use that we need to just set is open to false like this. Set is open to false. So if you connect it's already connected. Well, let's go back here. I did something. So in this place now, if you go down below, in this connector function, we have something here. We say if there is no address, that is when we want the connect wallet to appear. That's when we want the connect. But that means nobody has been connected to the DApp yet. But if not, we want to show. But if somebody has been connected, we want to show an address bar that will display the address. So now, how do we even get this address that we're going to use for conditioning? So the way we get this address, we have another to do here. Replace with the correct user address. So the way we get the address is that we have const. We have another hook from Starknet React called use account. So if you go back to Starknet React documentation, we have something here, use account. So this is used to access the currently connected accounts, if any. So this is how we use it. We first need to import it from Starknet React. Then when we call it, we have access to variables such as address, status, and others. So in these user accounts, we can now access the address, the currently connected address, if there is any address. So now we have this address here, so there's no need to have this. So if we just do this, if we go back to our code, you see that we have this address here, right? And if you open our agent wallet now, you see that this address, so you see that this address ends with EFOD, EF0D. That is the same thing that appears here in this address bar. So you see that we can see that we've actually connected to this DApp using the agent wallets. So I don't know if it's clear up to this point. So which is better to use, agent or bravos? Both are okay to use. So the only thing that agent has some more features such as account abstraction. But both of them, you can use both of them for development. You can use both of them for keeping your assets and all that. So there's no better one to use. So yeah. So is there any other question from anybody? Is there any from what we've done so far? So let me just go through what we've done. So basically, we implemented the connect functionality, which I said that in building DApps in Starknet, an individual's wallet counts as the individual's identity in a DApp. You know, normally in Web2, when you want to connect to like Facebook or Gmail, Facebook or Twitter, you make use of either your phone number or your email, which serves as your identity. But here you connect with your wallet, which serves as your identity. So now, the first thing that we did is that we got these variables, the connect and connectors variables, which was gotten from this hook, which is called use connect. So these connectors basically helps us to fetch the connectors available to this DApp, which we specified in the providers as agent and bravos. We also have this connect function that whenever it's called, it connects the DApp to the specified connector that was chosen. So then we have this connectors.map, which maps through the array of connectors to create a button for each of them. And when any of those buttons are clicked, we call the connect function with the selected connector, and that is how the wallet is being connected to the DApp. That's basically what we did here. So if there's any other question. So what is the best faucet for Starknet Sepolia? So for Starknet Sepolia, we have faucets. We have one from Vassell. Starknet faucets. So yes, so this is Starknet faucets. For this class, maybe while we are here, you guys can just paste in your Sepolia. Make sure that whenever any wallet you are using, make sure the network is set as Sepolia. So you can choose between Sepolia or mainnet. So we are going to make sure it's as Sepolia, whether agent or bravos. So you can copy your address and paste it in here. Then you select whether you want to either receive Stark or Ethereum. Then you request tokens, and this takes less than 10 seconds, 15 seconds, and you have your tokens to play around with. So you can see that in this wallet we have about 19 stack to play with that we can use for testing. So yeah, that's the best faucet for Starknet Sepolia. So what's the next thing that we're going to be doing now? So yes, if we are connecting, there should also be a way to disconnect now, right? So the way we disconnect is very easy. So in this address, so we go to this address bar. This address bar is what is being shown here. This whole component is called the address bar, like this. So in this address bar, we have so we're going to get a disconnect function. And how do we get a disconnect function? We have another hook from Starknet React which is called use disconnect, like this. So if you come back to Starknet React, we have use disconnect, and this returns two things: a disconnect function and an error variable here, like this. So this returns a disconnect here, like this. So this disconnect, we can remove this here. So disconnecting is very easy. So after getting the variable here, we have a button, disconnect wallet. Whenever the button is clicked, we just simply call disconnect, and that is as simple as that. So if we go back to our application, we are currently not connected. But if we connect to our agent, you see that we have our wallet address here, right? And if we click this, we can click disconnect. So you see that our wallet, so we can see that we have connect wallet. That means no wallet is being connected at this moment to the DApp. So disconnect wallet, you basically just call you import the disconnect function from Starknet React, call the hook, then you return the disconnect function here, which you can call whenever the disconnect button is being clicked, right here. So is there any question about that? So if there's no question, let's go on to the next thing. I think we are less now in the class. I hope everyone is following along. I'm not really hearing from everyone, so I don't know. Johnson, Maxi, Simon, Paul. I hope everything is going fine. So yeah. So since it's going okay, we're going to the next thing. The next thing that we're going to be learning is how to. So we're going to be learning how to fetch a connected user's wallet balance. So if you go back to our application, you notice that here we have this wallet balance here, and we need to fetch the balance in stack here. So how do we do that? So if you come to, we have a component called balance here, balance.jsx. So to do fetch connected users balance. So the way this is done is that you need to use like let's look at this. So we have fetch. So we have a function in hook called use balance, like this. So this is used to fetch the balance for a provided address and token. If no token is provided, the native currency is used, which is stack. So this is how it is being used. So you need to first import it. So we need to import it just above the components, like this. So import use balance. The next thing is that when calling this hook, we need to pass in an address, which is the address of the connected user. So how do we get the address of the connected user from what we've said before? The way we get it is by using something called use account, using the use account hook. And the use account hook returns an address parameter. So we have use account, like this, use account hook. So this address, this is a dummy address, so we can remove it and just put our newly gotten address, like this. Then we can also specify a token variable, like this. So we can get the Starknet token, but there's no need, because Stark is the native token for that wallet address. So we have this data here. If there's a data, we want to pass the float because it comes as a string. So we pass the float, then we put it to 3 decimal places, or if there's no data, we put it as 0 stack. So if we save this and we come to our, if we refresh. So this hook, I've been having problems with this hook for a while. It doesn't work as intended. So you see that it doesn't fetch the balance. But if we disconnect and connect again, okay. Okay, so I think it's using Ethereum. That is the native currency, sorry. So we have to get the contract address for Stack. So let me just go to it. So I'm going to be explaining what Voyager is. So Voyager is, remember when in our providers we selected an explorer. So Voyager is a Starknet explorer where we can use to check out contract addresses, and we can check out transactions that happen on the Starknet blockchain through Voyager. So on Voyager we switch from mainnet to Sepolia. Then we search STRK to get the stack token here. So the contract address, so we see the contract here. So in this balance we have token here like this, then we pass in the token address like this. So if we go back here and we connect our wallet, so if it's gonna connect again, so you see that we have our balance here as 19.9, but for some weird reason it goes back to 0, which I've not been able to figure out why yet. So if you go to our agent, you see that we have that exact figure, which is 19.943 displayed here. That was what was displayed here. So that's how you make use of the use balance hook to fetch the connected user's balance at any time. So yeah, so this error, in case you want to do error handling, you can make use of this error variable here. But for this session, it's really an introduction, so there's no need for that. So let me check if there's any question. So I hope everyone is following along. I know it sounds a bit complex, but if you rewatch the video, you can see how you can just learn it. And it might be hard for those who are really not familiar with front-end development. So maybe you could take a course or two on front-end development or how to build with React on Next.js, which I'll be happy to recommend some courses that you can use to learn it. Then maybe you could come back to this section and you'll have a better grasp of what we are doing here. So yes, but for now, just try to listen and follow along wherever you can. And also, if you have any question, no matter how small, you can always ask, raise your hand, and I will answer as swiftly as possible. So now we've been able to make use of the use balance hook. So now what is the next thing that we need to do? The next thing that we need to do is that, so let's check our readme to see that we are doing everything that we need to do. So we've gotten our RPC URL. So I'm coming, let me just get this. So we've gotten our RPC URL. We've also set up our providers. We've set up our connectors. We've implemented the disconnect functionality, and we fetched the user's balance. So now the next thing that we need to do is that we need to get our ABI from Voyager. And what is ABI? As we've said before, our ABI serves as the DNA of our contract. So we need to get the ABI first of all. So how do we get the ABI? So the way you get it is from Voyager, which is the Explorer as I mentioned. But to get that ABI, we need the contract address of the deployed contract. So I'm sure that you guys have been taught how to deploy smart contracts on Starknet. So if you go to the lib folder, you see data.js. Here you can see the contract address of these contracts like this. So if we copy this contract address, if you go to Voyager, so there are two types of explorers that we have on Starknet. We have both Voyager and we have StackScan. Personally, I like to use I like to use Voyager. So you can use any of them. So the main thing is that no matter what you want to use, you make sure that you toggle between the networks that you actually need. So if you paste this contract address now while using mainnet, nothing will be found because this contract was not deployed on mainnet, but it was deployed on Sepolia. So that means if you switch the network here and you paste in this address, it's loading, and you paste in this address, you see that the contract popped up because it was deployed on Sepolia. So let's use Voyager instead. So on Voyager now, if you paste, remember the network here is set as Sepolia. So make sure you check out for this, because it can be quite frustrating when maybe you've deployed the contract, but you're trying to search for it, but it's not popping up. It's not popping up. But so you have to make sure that you check for, make sure that the network is set to what you deploy the contract on. If not, it will not show up. So if you paste it here, you can see the contract here. So you select it. So if you scroll down, you have like information about the contract, such as the contract address, the balance, when it was deployed, who it was deployed by, the time it was deployed. We have the class hash also. So the main part is when you come down here, contract data. So here you can see transactions done on this contract, token transfers, bridge transactions, events, messages, account calls, code, class history, read contract, write contract, read storage. So let's look at these read contracts first. In this read contract, this is where you see all the read functions available for that contract. So remember from the contract I showed you, let's go back to the contract a bit. So in the contract I showed you, so for the read function, we have get students here, which you can also see here. And you need to pass in an index as also specified here. Then we also have get all students. It's also a read function. So we can actually interact with our contract directly from here on Voyager or StackScan. So if we try to get all students here, we can query this thing here. So if we change this to text, you can see all the students that have been created so far in this contract, like this, in an array. So now we see this ID. So we can actually fetch, we can get the students by ID. So let's say we want to get the second student, which is 0x02, and we query. You see that it's Peter Apostle. And if you go back and you fetch, you see that the second one is actually Peter Apostle. So you see that it works. You can interact with the contracts directly from here. So I'm going to send you a link so that you guys can also check it. So you can also play with it on Voyager too. So yeah. So we also have the rights. So if you notice, when calling this read function, we do not need to connect our wallets, because we don't need to sign any transaction. There's no transaction that is being occurred whenever we call read functions. So that means there's no gas fees. But when we want to call a write contract function, we need to connect our wallets. If not, this transact is not working. You see, please connect your wallets in order to transact. So now, if we can connect to either one of them, so I'll connect to my agents. So let's create a new student. So let's say Timothy Brown, like this. Let's give a phone number of 0905. So yeah, then age, let's give it 42. Then he's active. Let's say yes, he's active. So if we transact this now, so we have this little warning. So if we confirm, so if we transact again, so our wallet pops up to sign the transaction. So we have an error. I think the error is from this is active. So let's say 0x1. see if this works now. Okay, yes. So actually we also have, so this is, so as we all know from our previous classes in Starknet, with Starknet, Cairo does not make use of strings. They make use of something called felt 252, and these are actually strings. So we need to convert them to felt 252 when trying to interact with them here on Explorer. So there's something called starkutils. Starkutils. This is basically a tool for converting between types in Cairo or Starknet. So let's say we want to have Timothy here. So this is the first value of Timothy. So if you come here, you have to paste this. Then the last name, you said Brown. So we have the first value of Brown. So we come here like this. So let's see if this works. So you see that it works because it only accepts felt 252. So if you confirm this now, so that transaction goes through. So if you go back to our read contract to get all students, if we query it, you see that the last one is Timothy Brown here. So I hope you can see how, like, you can see that we interacted directly with our smart contract through our Explorer, right? So that's, so let me send you the starkutils converter that you can make use of. So you can see that you can also, in this stack, felt 252, hex, string, felt array, byte array, selector, U256, big 3, and so on. So that is how it works. So let me still show you that, like, that it actually works. So if we convert our response to back to, I think, decimal, if we get this last name here, so this is felt 252, right? So if you come to our starkutils and we paste it back here, you see that the string equivalent is Timothy, right? So if you, let me increase it. So you see that it's also Timothy. So you see that means it works. It works for all types. You can convert from string to felt and so on and so on. So that is how it works. So yes. So what brought us here was to get our ABI. So the way you get your ABI is by coming to this code section here. So you see contract ABI. So you copy the whole contract here like this. So if you copy the whole contract, so contract ABI. So we have a folder called ABIs here. So you have ABI.js. So to do get ABI from Voyager, so you just replace this empty array with the correct contract. So you see, so this is the ABI. So we've gotten the ABI successfully from the contract from Voyager. So let's have a closer look at this ABI. We said it's the DNA, right? So you see, first of all, we have the name of the implementation used in this contract. Then we have the structs available for this contract. So we have a student struct, and every student struct has the following members. We have an ID. So if you go back to Voyager, whenever we're reading from the contract, you see that we have ID, F name, L name, phone number, age, and is active. And that is the same thing that you see. ID, first name, last name, phone number, age, and is active.
What's the use of the ABI?
What?
What's the use of the ABI? If I told someone wants to know.
Okay, what's the use of the ABI? So the ABI basically serves as the DNA, and it helps us to interact with our smart contracts. So it's just a prerequisite that is needed, basically. So that's how it works. So, but as you see how the API is being used. Sorry. You see how the API is being used. So yeah. So if we go back to our README, um, so the API, we've gotten the API. The next thing so we're almost done. So the next thing we need to do is we need to fetch students from contracts. So the way we call this function here, call this function from our front end. So that is fetch students from the contract. So how do we do that? So the way we do it is that we go back to our page.jsx and we fetch the students here. So currently now we are using dummy students. So we have some dummy students that we're using. So we don't want to use this dummy. We want to fetch the student directly from the contract. So the way we do that is that, first of all, we're going to make use of another Starknet REact hook, which is called use read contracts. So use contract read. So this is the hook that we use to make read calls to a contract. So now let's do so here. So we have const. So it returns some things. So you say use contract read like this. Use contract read. So this use contract read, we need to pass in some things. So we pass in an object. The first thing we need to pass in that object is the function name. What function are we trying to call? So if you go back to our API, we can see the functions available. So we see the first function now that we have here is add students. So we have the type is of type function. The name is add students. Then we have the inputs that function receives. Then we have the output. What does it output? And you see that it outputs a boolean. Then we see state mutability external, which means it mutates states. We also have another function, get students, which shows us the type, the name, the input, and the outputs, and whether the mutability is view or external. Then this is the function we're interested in, get all students. And we can clearly see that the inputs, it does not require any input at all. But what about the outputs? The output returns an array of the struct students. So from this API now, we can get all the information that we need for every function that is in this contract. So you can see how the API is important. So this is the function we are trying to call, get all students. So we go back to page.jsx, we pass that in. So this is the function we are calling. The next argument is that we need to pass API. We don't have any inputs for this function. That means we can leave it empty as an empty array. The next thing is we need to pass in the API like this. So this API now, so in this API we're exporting the API like this, so we can easily import it in that page. So we have API. So we have API like this. The next thing is the address, which is the contract address. And in our file, which is data.js, we have this variable called contract address, which is exported. So we can just do contracts. We can just import contract address like this. So that is basically it. So what does this use contract return? So the first thing that it returns is the data. It returns the data, which we are going to rename to all students. To all students like this. The next thing that it returns is that it returns an is loading variable, which is a boolean. Whether it is loading now. When you are fetching something from maybe a server, it takes a little time. So while it is fetching, its loading is set to true. Then when it is gotten, it's set to false. So that's what the is loading is. So we can rename this to is loading. The reason why we are renaming it is because just imagine a situation where we are fetching multiple things in this same in this same file, no matter the number of times you use contract tree, it's always going to return data is loading. So if there are multiple data, it's going to be very confusing for the compiler. So you rename it to suit whatever is returning. So that is why we are renaming all these variables here. Then we also have something called the refetch. So this is a function that helps us to refetch information. So let's say refetch students like this. Refetch students. Then we have is fetching, which is also a boolean to say whether it is fetching or not. Is fetching. You see, it's fetching students like this. So yes, so this is it. So let's see. So if you unclick this now, so we are constantly logging all students to see what we get from the smart contract. So if we go back here, if we inspect, we go to our console, you see that we already have an array here that comes with all the students that we have. We have 7 students. So we have the first one, which is name, age, first name, ID is active, L name, phone number. So you see the whole 7 students have been returned to us here. So if you notice that our first name and last name is not coming in the form of strings. It's actually coming in the form of felt 252. That is why it's not being displayed in the main page itself. So you see, this is how you read from a contract. So this is as simple as doing this. So I don't know if there's any question regarding this. Does anybody have any question?
So in case you...
So there's no question.
I have a question. In case you haven't used the data types properly, it won't be fetched.
In case what?
You haven't used the data types properly. Won't you get the data when you try to fetch?
That means you're talking about maybe in the ABI.
Yes.
Are you talking about the surname and first name coming as felt 252?
Yeah, I'm talking about from the front end, the surname and first name coming as a 252.
Okay, so it comes like that normally because that is the data type that Cairo recognizes. So there are utility functions that you can create that can convert felt 252 to normal strings that you and I know. So I'm going to show you that right now. So first of all, the first thing we need to do is that I have something here which is like a loading state. So if you refresh this, you see that everywhere is empty for a while, which is not really good UX, user experience. So we need to have like a loading state. So I just have something here. So in this line 65, you can just remove line 65, and we have this small conditional which says that whenever is loading students is true or is fetching students is true, we want to display a loading state. If not, we should display the normal table. So if you refresh this, okay, I didn't save it. So if you refresh it, you see that we have a loading state to show fetching students. So the next thing that let's look at this refresh. Let's refresh students. Whenever maybe we add a student and it does not reflect on time, we have this simple button here that is used to refresh the students, but currently it's not working. So we need to make it functional. So what you just do is that in this student table control, we have a prop here which is called handle refresh students. So this function is called whenever that button is clicked. So whenever that button is clicked, we want to it's just as simple as calling this function that we've gotten here, refetch students. So here you just do refetch students like this. We just call the function as simple as that. So if we click it, you see that it refreshes the students for us very simply. So this is how it works. So now the next thing that we're going to be looking at is how we can convert our file252 back to strings that you and I know. So if you go to the lib folder here, we have something called helpers. So I already have a function written here which converts file252 to string. So you pass in the first value, then it does some computation and returns the string to us. So this is something that you can just copy and paste and keep somewhere for you to use like later in the future. So if we go to our table components and you go to the table row, you see that we are just calling students.lastname, student.fname here. So we can just remove this and we can just this is where we now make use of the file252 to string variable that we have. So a function that we have where we pass in the felt value like this and this, and it works. And if you go back, you see that it works perfectly. So it has converted it. I remember the one that we created newly, which is Timothy Brown. So you can see it right here, 42 years, and this is the status and all that. So you see how it's very easy to read. So you can see how very easy it is to read from the contract. So it's just as simple as doing this. This is basically the whole thing. You basically call the use contract read function. You pass in all the arguments, such as the function name, the arguments, the ABI, and the address. Then you get all this information that you can use in your application. So this is how you read from contracts on using your front end. So I don't know if it's clear. If there's any question, Tech, do you have any question?
No questions from me.
You guys are not responsive.
Maybe like are we going to have the finished like GitHub?
The finished code.
Yes.
Yeah, that's going to be provided. I'm going to push it as soon as
something
ends. So, what is the relationship between the provider and the ABI? So, there's no relationship between the provider and the ABI. The provider just basically, okay, let me show you guys what I mean. Why this provider is important. So, imagine we don't have our provider here in this layout. You just have children. If we don't have our provider, we will not be able to use all these hooks that we are using, such as the use disconnect, use connect. We will not be able to access it at all. So if we have this error, use starknet must be used within a starknet provider or starknet config. So it's illegal for us to make use of anything concerning starknet when we don't have a provider, right? If you don't have starknet, if you don't have Starlink installed in your house, you cannot just go to your Wi-Fi and be looking for Starlink to connect to, because you've not set up your or maybe let's use electricity. If you've not wrapped your house with electricity, you cannot go and connect your charger to an outlet. It will not work, right? That is what the provider does. So that provider, it actually provides starknet services which you can use to interact with your smart contract when doing front-end integration. While your ABI is basically, it just serves as like a format. The way I read it is that the ABI just basically shows, oh, this is what, when you call this function, you need to pass in this. It's like a blueprint. With this ABI now, you can know everything that you need to know about this contract. You can know the functions of each contract. In that function, you can know the inputs that function requires, the outputs, and so on. That is basically what the ABI does. So there's no real relationship between them. I hope I was able to answer you. So Vianney, so you're asking a question. Okay, so it's clear then. How about you, Joanne, Johnson, Simon, Paul, Maria?
I think many of them are going to follow along.
No, we're not done. We have one more thing now to learn how to write. We've learned how to read. Now we want to learn how to call write functions.
So maybe I have a question.
Okay.
On the API, like, do you already have to use that API, or you can get another API?
You have to use that specific API.
Okay.
Yes. So does anyone have any other question? Okay. So if nobody has any question, we can move on. So the next thing we're going to be learning how to do is we're going to learn how to we're going to implement the functionality to add a student, which is basically calling a write function. So this is going to be a long one, kind of, but you just try to follow me. So if you go to our page.jsx and go to table control, we have this add student function, which pops up a dialog here. So we have a dialog, so which is like a form. Okay, let's put back our providers like this. So if you go back to the providers, so everything works perfectly now. So if you add a student, you type in the surname, the first name, and the age, and you submit. So let us do that now. So we're going to be doing that in the students table control. So in this student table control, so this is the last thing. So the first thing that we're going to be doing is that whenever you want to write to a contract, you need to initialize a contract. You use a contract initialization, and that is as simple as doing const. You make use of the use contract hook. You use contract hook like this, and you pass in an object. So you pass in the API first of all. You pass in the API and you pass in the address. Then you pass in the address like this. So the address, we can also import it from contract address like this. So this use contract returns a variable called the contract. The contract. So this is the first thing that you do. The next thing that you need to do is that you need to create a contract call array. So this is just basically an array of calls because whenever you're calling a write function, you are making a call to the contract. So we have something called const calls like this, which is going to be equal to, we're going to be using a use memo for memoization, so that for optimization. So in this use memo, so we're going to check whether so in this use memo we're going to return first of all. We're going to be returning. We have we have a method called populate transaction. So in this populate transaction, you now type in the function name, which is add students like this. This populate transaction add students. Then you're going to now put in, you're not going to put in the arguments. So you have something called call data. Call data from Starknet. So call data does compile. What this call data dot compile does is that, whenever we're adding a student, this form takes in strings. So what it does is that it converts the strings that were passed in to the appropriate type accepted by the function. So for surname, instead of it's going to convert the string to file 252, the first name to file 252, the phone number to U8, so to file 252, the age to U8, and so on. That is what this call data does compile does. That's what it does. So you pass in an array. So we already have the variables passed in. So we have the variables from that form here: surname, first name, phone number, and age. So we pass in the first name, then we pass in the surname, the phone number, the age. Then we also need to pass in whether it is active or not. So by default, whenever a student is created, it is going to be active, and that is true or false. So we can either pass in 0 or 1, and it's going to convert to either true or false for us. So in this memorization, this is dependent on whenever the contract changes, or the user changes, or the first name changes, or surname changes, or phone number changes, or age changes. So that is how memorization works for optimization. So one thing that we need to do is that we need to make sure that this core array is only called, or is only populated whenever we have everything completed, because it does not make sense for us to have user is not defined. So we need to make sure that we have a user. So we need to initialize the user first of all. So const we have const account is equal to use account, like this, or let's use address instead. So this is going to serve as our user, the connected user. So I think that should work now. Okay, so so you notice now that currently everything is empty. By default, the element in that form is set at 0. So it's saying that we cannot convert 0 to a big int. So that's why we need to now have a check before anything is being returned in this calls array. We need to do something here to check whether we need to have like a variable called cost is input valid. So what this is input valid does is basically it checks to make sure that we have all inputs filled before anything is returned. So its input valid is only going to be valid when we have a user, and we have a contract, and first name dot length is greater than 0, and surname dot length is greater than 0, and phone number dot length is greater than 0, and there is an age. That is the only time. So I won't say if is not input valid, we want to return an empty array instead. So this check cancels out that error for us. So you see how everything works normally. So if you add a student, so now that is the call. That's the first step. That's like the second step in doing everything. The next thing that we need to do is that we need to now make use of the right hook. We have a read hook. So for the right hook, we have something called use contract rights. So we have const. This is equal to use contract rights from Starknet React also. And this takes in the call. It just takes in the calls that we specified like this. But what does it return? So the first thing it returns is that it returns the write function, the function that we call to actually write the contract. Then it also returns data. That is the write. So we can rename this to write data. Write data like this. Then the next thing that we need is pending. So it also returns is pending. So you say we can rename this to write is pending. Write is pending like this. Then so yes. So this is it. So then we have a handle submit function here. This is a handle submit function. So whenever we filled everything, after we filled everything, if we click this button, it submits. So we have to call the write function. It's as simple as calling that write async function like this. So that is the function that we get here. So this is what we call right here. So let's test it out whether it works. Let's add a new student. Let's say Jonathan. Let's see the first name, Jonathan Adams. We have a phone number here, and let's give it 20. So let's submit. So we have an error. This error is probably because we have not connected our wallet. So let's connect our wallet. You connect your wallet. So after you've connected your wallet, so let's see Jonathan Adams, and E should be 32. So if you submit, so you see that it brings us to our wallet. We sign the transaction. So let's check. So it's not here. So this is where we can now have our refresh students. The functionality comes in. So if you refresh our students, you see that we now have 8 students. Jonathan Adams, the phone number and the age that we specified, and it's active. So you see that we've successfully written to the contract. So if there's any question, you can just type it into the contract. So now, but we need to have some form of loading to show that it's loaded. So we just have some base. It's just something we can do to check the process of the transaction being signed. So there's also another hook that I'm going to just show you. It's not really necessary, but I'll just show you just so you guys can know about it. So there's this hook called use wait for transaction, like this, use wait for transaction. So if you check it, so this takes in the hash and the watch variable. So we set it to true. So how do we get the hash? So do we get the hash is that we get it from this write data here. So the write data returns something called the hash. So write data dot transaction hash like this, and this is how you get so this returns some couple of things. So it returns an is loading state here like this. So you see wait is loading. So wait is loading. Then we have the data. So we have this is wait data. These are the two things that it returns. So this is use wait for transaction. So this waits for the transaction. Then we have a simple loading. So we have a loading state here. So we have what we call button context. content is this is currently commented out. So if we uncomment it, sorry, if we uncomment it like this, so button content. So what this button content does is that we say if write is pending, we want a loading state to show sending. If it is loading, we want it to show waiting for confirmation. If there's a wait data and is a wait data dot status is equal to rejected, we want to say transaction rejected. But if there's wait data, we want to say transaction confirmed. If not, we should just return add students. So where we put this is that we'll just put it down here. So instead of submit, we just have this button contents here. So let's see how it works. Cannot read properties of transaction hash. So it's possibly undefined. So the way you just put this question mark here. So this optional chaining. So let's add a new student now. So we have add student here as the text. So let's say we want Wilson Parker. The phone number should be, let's say this, then the age should be 22. Right? So if you click on add student, okay, we're not connected. So let me connect my wallet again. So if you add a new student, so we say Wilson Parker, phone number 22. So if you click on add students, you notice that the text is supposed to show. I think we put this watch. This watch is not needed. Let me do that again. So add students. Let's see Wilson Parker. So we see 22. So you see that it changes to sending. It's currently sending. Then when we click confirm, you see that it's supposed to change, but the transaction is going so fast, so you cannot see the loading states accurately. So if you go back and we check if you refresh students, you see that Wilson Parker has been added. So this is how you write to a contract in Starknet integrations, basically. So this is everything that we have done for today. So let me try and refresh what we did when writing to a contract. The first thing that we're going to do is that we are meant to initialize the contract, because it's one of the inputs needed when calling use contract rights. So to initialize the contract, you make use of the use contract hook, which takes in the ABI and the contract address, and this returns a contract to us, right? The next thing that we do is that we need to initialize a contract call array. So this is going to be the call that we are making to the contract. So in this contract call array, we are going to first check whether all our inputs are valid. That means whether we have inputs or not. So we're going to check whether our inputs are valid. And it's only when inputs are not valid, we want to return an empty array. But when we have valid input, we want to return a populated transaction. So we call contract.populate transaction, where we pass in the function name we want to call, then the arguments. So we are going to be compiling the arguments to convert it to the type specified in the contract. So we have call data.compile, first name, surname, phone number, age, and is active. And this calls arrays meant to repopulate anytime the contract changes or the user, whenever any of these in this dependency array changes. The next thing we do is that we make use of the use contract rights from hook. So which takes in the calls. Then it returns the rights function to us, the right data, and the right is pending variable to us. Then we have use wait for transaction. Which is also another variable, which is also another hook that we make use of to wait for a transaction to complete, which returns the is loading variable and the data variable. but we need to pass in the hash and the watch, whether we are watching for it or not. So that is basically how you write to a Starknet smart contract. So I don't know if there's any questions so far.
Isn't there any gas fees involved when I'm writing?
Yes, yes, definitely. So you always pay a gas fee because you are mutating states. So it's a transaction. It's the same thing as sending crypto. Because you are also changing, because sending crypto is also changing states on the blockchain. So that's how it works. So let me show you like how it is exactly. So if you add a student, so you add a student. So if you see it here, you see estimated fee. So in this estimated fee, you can see we are going to be making use of 0.037 stack to execute this transaction. So that is the gas fee. So does anybody have any other question? Joanne, Simon, Paul, Manuel, Mark Mods. So I also said I was going to recommend some front-end courses for you guys to go to, so that you can be able to go through it, so that it makes, so whenever you revisit this recording or session, some things become clearer to you, so you understand better what we did. But because of time, we could not really go through those basic fundamentals of React and Next.js. So on Udemy, you have this course. So we have so the first step is always learning HTML and CSS. Then we have the next thing is JavaScript. So we have this complete JavaScript course by Jonas Schmedman. So you can easily, it's a 70-hour course where you learn everything that you need to about JavaScript. So this is going to help you in your front-end journey. If you decide you want to go further in front, then after learning JavaScript, you can go to, he also has a React course, React Next.js course here by the same person. So after learning JavaScript, you can learn, so it teaches React and Next.js. So it teaches you everything that you need to know also. So it's an 83-hour course. So it's very long, but it's well worth it, because these are things that I personally use to learn these things, and I can see that it's like of good quality. So yeah, so that is basically it for today. So I'm going to push this code to a new branch, and I'm going to share it on the group chat so you guys can go through it and relieve. And if there's any question that you may face when trying this out, you can always text me on the group, or I will leave my social media details for you so you can go through it and see how it works. So I don't know if anybody wants to say anything, or if there was any confusion or anything.
Thank you so much, Oshioke. Yeah, it has been clear, and I know some guys had issues with their network, but they always go back and rewatch the videos. But yeah, we really appreciate you've at least showed the basic, the real fundamental, the writing to the blockchain and getting from the blockchain. You talked about the assignments. You put them in the group. I saw, as if I saw it in the group. Yeah.
Okay, so for the assignment, let me just say it. Sorry, I almost forgot about that. So for the assignments, basically what I want you guys to do is that I want you guys to make this the edit and delete students functionality work. So whenever you click on this edit, it's supposed to be a pop-up modal that will edit that particular student. Then if you submit it, when you refresh the students, it's supposed to edit the students. The same thing with this delete. But notice that this delete button does not actually delete the students, but turns their status to inactive. It turns this active status to false. So you see all these ones with green checks. That means the students are active. So whenever you delete this, it's supposed to change to an X. That is basically the assignments. So they are both right functions. So you just create those components and make sure they work perfectly. So that is the assignments. So if you also go to the code base, I have it written in the assignments.md. So this is basically it.
Oh, thank you. It's pretty clear. I can see it. So whatever you've done, it can be
Yes.
accessed on the repo.
Yes, I'm going to push it to the another branch where everyone can access it.
Okay. Okay.
Okay, so one thing I would say last is that you guys should keep on trying out new things. You watch the video as much times as you need, and you can always ask questions. So you have to practice and practice and practice, and that makes you a better developer on Starknet. So it was nice. It was a pleasure taking you guys this session, and I hope I was able to impact some knowledge in you guys, and I hope to do it some other time. Thank you. Thank you, and the Central Code and the Uganda community, the Uganda Starknet community, for giving me this opportunity.
Thank you so much. We really appreciate.